lecture notes. We were doing part L, correct? And it said if you saw all 5 people developing the disease, would that be unusual? That's what we were talking about, correct? So give me an N and give me a P for that problem. N was 5, part L. N was 5. What was P? Was it 1/4? Yep, 1/4. And the question was, is R equal 5 successes unusual? That's the question, right? So we have a rule that says R successes are unusually high if probability x greater than or equal to R is less than or equal to 0.05. That's the rule. So we had found that the probability of 5 was 0.00097, which we said, let's just call that 0.001, something like that. Is that right? Can you check that number, please? Is that correct? So we're saying that this is what we're doing. We have some binomial distribution, and we want to see if 5 is considered unusual. So we have to take 5 and everything that comes after 5, which in this case there's nothing, right? And see if that's less than 5%. So certainly 0.001 is less than 5%. Therefore, 5 would be considered unusual. How about 4 successes? Would 4 successes be considered unusual? Who knows? Let's see. So let's make a part M. I'm making it up, okay? You're going to see this on your test, so I'm elaborating on it. Would 4 successes be unusual? So I'm following the rule here that says if 4 successes are to be unusual, then the probability of 4 or more, so or 5, add up those probabilities, and if that is less than or equal to 0.05, that would mean that 4 is already too far gone, that the probability of being even worse than it is so small that it's not in the usual range of values. Does that make sense? If the probability of 4 or more is tiny, it means that 4 is too far away from the usual values, that the probability of being even more extreme than that is very small. That means there's nothing usual about 4, because if 4 were a usual value, it would be somewhere closer to the center, wouldn't it? So that the probability of being more than it would be greater than 5%. Are you understanding me? Okay, so what was the probability of 4 in this problem? Remember, we created a whole table of values. It's on the other page. If you flip, yeah, read me the probability of 4. 0.0146 is the probability of 4. And the probability of 5 we just said was 0.001. So when I add these together, I still get 0.0147 0.0156, which of course is smaller than 0.05. Therefore, even 4 is unusual. Are you getting me? Are you following me? How about 3? Would 3 be unusual? Let's see. Part N. I'm making up these, of course. Would 3 be unusual? So I'm going to take probability of 3. Let's draw a picture so it makes it very clear. And 4 and 5, because I have to take 3 and everything above 3. It's like p-value. I'm finding p-value here, right? Probability of being more extreme than that. So I'm going to take 3 and 4 and 5 and add them. So, Miss, can you read me the probability of 3 again? Because I've already found it. 0.0879. Wow, it's already greater than or equal to 5. It's already bigger than 5%, right? So certainly 0.0879 plus 0.0146 plus 0.001, all that added together, the sum is not less than or equal to 0.05. Not less than or equal to 0.05. Therefore, 3 is not unusual. Is it perfectly clear? How about unusually low? I want you to tell me right now if 2 would be an unusually low value for this problem. See, luckily for us, we've already found all the probabilities, right? But on your exam, you wouldn't have found that distribution, so you would have to figure out what those probabilities are. So let's make a part O. Is 2 to be considered unusually low? What do you think? The rule is our successes are unusually low if the probability of x less than or equal to r is less than or equal to 0.05. In other words, now go more extreme into the left tail. So I'm interested in probability of 2 or 1 or 0. Right? How would I find this in one step? I know that we've already found the individual probabilities, but had we not, how would I find it? Binomial what? CDF. Binomial CDF of NP2. So N, of course, is 5, and P is a quarter. Can you find me this number? Binomial CDF of 5, comma, 1/4, comma, 2. I expect a really large number. How come you're not, you guys have to pull out your calculator and do it right now? How come your calculators are not out? Yeah, 0.897, right? Huge probability. So I took the sum of all of these because I want 2 or less. Yes? Okay, I'll go back to the previous question in just 1 second. So 0.897 is not less than or equal to 0.05, so there's nothing unusual about two people developing the disease after exposure. Does this make sense? Bless you. Okay, previous question. Let's see. There's a question about the previous question. Would 3 be unusual? That one? So you want, the quick way to do this would be 1 minus binomial CDF of NP2. Yeah, which is what we did. So it would be 1 minus 0.897, right? Why not? Did you get something close? So this is 0.9 basically, right? 1 minus 0.9. 0.897 is 0.9. So did you get roughly 10%? 0.103 is 0.10, right? So what I'm saying is, I know what you're saying to me, but look at the rounding. This is roughly 0.9, right? So this is 0.9 and this is 1 minus 0.9. So my answer is roughly 10%, which is not less than 5%. So don't worry about the third place after the decimal or something like that. Roughly speaking, is it less than 5% or is it greater than 5%? So it's double of 5%. That's what I'm trying to say. Get it? So basically, we're talking p-value here. You see that, right? P-value is the probability of being more extreme than where you are. More extreme to the right or more extreme to the left, depending on whether you're unusually high or unusually low. Get it? Okay. Any question on this? Let's go to the beginning of the chapter and fill in all the blanks that we didn't fill in. So what page was this on? Let me just label these pages properly. Would you tell me what page part L was on?
11.
Page 11. Okay, so this is lecture what, 6? Is this lecture 6? Lecture 6, page 1 of the type notes. So this is the stuff that we had skipped last time, and now I have to go back and fill in the blanks that I had left out. So it says that random variables are denoted by capital letters. X is a discrete random variable, and the PMF of X, probability mass function, looks like this: xi p of xi. So here I would have my x1 through xn and p of x1 through p of xn. And just to reiterate, there are two rules that must hold. It says so right here in the middle of the first paragraph. The two rules that must hold for probability mass functions are the following. One, P of xi has to be greater than or equal to 0 for all I. That means all the probabilities must be non-negative. And secondly, the summation of P of xi has to be 1 for I going from 1 to n. That means this total has to be 100%. We know that already. We use those rules for binomial, right? I would like to talk about the formula on the bottom of page 1, which is the expectation of a random variable x. So let's define that. E of x is the mean, or the expected value, and is given by the following formula: summation xi P of xi. So you see, I have a bunch of values here, right? Let me make up some function. How about a function like this? Xi, P of xi. How about something like this? Minus 40 with probability 7/8 and plus 2 with probability 1/8. Here's my probability mass function. So my first question to you, is this a valid function? Two rules would have to hold, right? P of xi would have to be non-negative, and the sum of the probabilities would have to be 1. Are those conditions satisfied by this function? Yes or no? Does this minus bother you? It shouldn't, right? This is just a loss. It's saying that you lose 47/8 of the time, you make $2 1/8 of the time, something like that, right? Kind of like when you go to Atlantic City, right? So 2 conditions are satisfied. All the probabilities are non-negative, and summation of P of xi is equal to 1. Therefore, this is a valid probability mass function. I would like to find the expectation of this function. Would it be fair to add down these and divide by 2? Can I just say minus 40 plus 2 divided by 2 if I want the mean? After all, this means mean, right? Mu. Can I do that or no? No, you cannot do that because this occurs 7 times as much as this value, right? So E of x would have to be minus 40 times 7/8 plus 2 times 1/8, meaning this occurs this much of the time, this occurs this much of the time. Let's do that. So what do we get when we do this? 8 goes into 45 times, so I get minus 35 plus 1/4. So this would be minus 34 3/4. Agree? That's E of x, expected value of x. How would you do this on your calculator? Because all your probability mass functions are not going to consist of only 2 values. This could be 5 different values adding up to 1, whose probabilities add up to 1, right? So how would you do this on your calculator? It's very simple. You just put this xi into L1, put this into L1, and this into L2. And then you go stat, calc, 1 variable statistics on L1 comma L2. If you forget the comma L2, it would not be reading the probabilities at all, and it would give you the answer minus 40 plus 2 divided by 2, which would then be minus 19 for the mean. And of course, that would be wrong, right? You follow what I'm saying? You cannot forget this L2. It's very important because it's telling the calculator these values in L1 occur with different multiplicity, different probabilities. So you cannot ignore that. So please do this right now and tell me if you see the minus 34 and 3/4 or not. Yes. Yes. So if your calculator doesn't allow you to just put it in as a comma, then it would be in the frequency column. Yeah. It depends on the version of the TI-84 Plus. Is that what you have? Okay, then yeah, frequency. Everybody okay? All right. Let's talk about the formula on the bottom of page 2 of the typed notes. Page 2 bottom is the next formula. It says E of H of X. E means expectation, right? E is saying expected value of H of X equals summation H of Xi times P of Xi. I just want you to stare at this for a second, at this formula for 1 minute, okay? Look at this. When I was looking for E of X, I did summation Xi P of Xi. So this, and this have to match up. That's all. When you're looking for the expectation of X, it's summation Xi P of Xi. When you're looking for the E of H of X, it's summation H of Xi P of Xi. So these match. And then this is simply the probability of the original X, this X random variable. Follow? So if I were looking for E of X squared for my function above, then this would be summation Xi square P of Xi. These have to match, that's what I'm trying to say. So if that were the case, I would say minus 40 squared. I'm taking my first x and squaring it, times 7/8 plus 2 square times 1/8. Get it? Yes or no? Okay, can you find me E of X cubed for this function? E of X cubed. Summation what? What would I say there? Xi cubed P of Xi. Notice that this remains probability of Xi, the original function, right? So let's cube it. Minus 40 cubed times 7/8 plus 2 cubed, 1/8. And then we would just clean that up, right? I'm not so much interested in the answer as the procedure. Follow? Okay, what if I wanted E of 3x? What if I wanted E of 3x? This would be summation 3xi P of xi. Again, these match. That's all. So there are two ways to do this. You could either find 3 times every x and times by the probability like this. 3 times minus 40, 3 times minus 40, times 7/8 plus 3 times 2 times 1/8. You could do that, in which case you're going to get minus 37, no, sorry, minus 120 times 7/8 plus 6/8. Minus 105 plus 6/8. Is that right? Let's see. I don't think so. 8, 5, minus 105 plus 6/8, which is minus 105 plus 3/4, which is minus 105, 104 and 1/4. Not the best way to do this problem. You could have said E of 3x is equal to, pull this constant out, 3 E of x. And E of x was already found on the previous page, minus 34 3/4. So how about saying 3 times minus 34 3/4? Do you get the same answer? Do you get the same answer? Let's see, 3 4s are 12, carry 1, 3 3s are 9, and 1 is 10, minus 102, plus minus 3 times 3/4. So minus 9/4, minus 102. Same answer, minus 104 1/4. I don't have a calculator in my hand, so I'm trying to do it. So naturally, this is much simpler. When you're trying to find E of 3x, you just pull out the 3 and then do E of x, which we had already done previously, right? Similarly, if I wanted E of 10x squared, I would just do 10 E of x squared. Pull this out. That's all. Okay, so it says on the bottom of page 2, for the fair die, compute E of x squared. Can we do that problem? For the fair die, page 2 of the type notes, bottom. Find E of x squared for the fair die. So this PMF for the fair die looks like this: xi, p of xi, 1 through 6, and probability is 1/6 throughout. So for E of x squared, I would have to do summation xi squared, p of xi. These match. That's all that's important, right? So square the x and times by the probability. But in this case, all the probabilities are 1/6. So how about I pull that out? Because this happens to be 1/6 throughout. So can I say 1/6? They're all 1/6, right? Times summation xi squared. So 1 squared plus 2 squared plus 3 squared plus 4 squared plus 5 squared plus 6 squared. So 1/6 times 1 plus 4 plus 9 plus 16 plus 25 plus 36. Let's see, 36 and 4 is 40, and 10 is 50, and another 41 is 91. So 91 over 6. 6 ones are 6, 6 fives are 30, and 1/6. 15 and 1/6. Get it? Okay, I have a question for you. Let's say that I'd like to play a game with you. I will charge you $5 to play this game, and I will give you 2 times the square of whatever shows up on a die that you roll. You roll a die. It's going to cost you $5 to play this game. And I will give you 2 times the amount. So here, the payoff will be 2 times what shows up, the square of what shows up on the die. 2 times the square of what shows up on the die. But it's going to cost you $5 to play this game. Should you play this game? So I'm going to find the expected value, right? Find expected payoff. So E of payoff equals E of 2x squared minus 5. So this would be E of 2x squared minus E of 5. Let's pull the 2 out. So this would be 2E of x squared minus E of 5. E of 5 is 5. E of a constant is the constant. If you have a constant function, the mean of that function is that same constant value, right? Look at this. E of 5 is 5, because if I have constant of 5, then the mean of that is also 5. Mean of that whole function is also 5. So all I have to do in this example is 2 times E of x squared, which had turned out to be 91 over 6, right? For the fair die, minus 5. So 2 goes into 6 3 times. So this is 3 goes into 9, 3 and 0 and 1/3 minus 5. So you're expected to make $25 and 1/3 dollars when you play this game. So should you play this game? The answer is yes, you should play this game. Do you follow? Any questions on this? What if you hadn't already found E of x squared? Then how would you do this problem? See, this was very convenient for me because I had already found this value, right? What if I hadn't found that value? Then what would I have had to do? Do you understand the question? I'm saying on the previous page, I had already found E of x squared equals 91 over 6. So I just went and used it. But what if that wasn't found already? How would you have had to do the problem? You would have had to do this. E of 2x squared minus 5 equals summation 2xi squared minus 5 times p of xi. Are you following? Because if I give you some strange function, you're not going to know what the e of x squared is, right? So you would probably have to do this. So how would I do this? 2xi squared minus 5. This is my function, right? xi 1, 2, 3, 4, 5, 6. I would have to create whatever this thing is here. 2xi squared minus 5. So 2 times 1 minus 5 is negative 3. And 2 times 4 minus 5 is 3. And 2 times 9 minus 5 is 13. And 2 times 16 minus 5 is 32 minus 5 is 27. And 2 times 25 minus 5 is 45. And 2 times 36 minus 5, 72 minus 5 is 67. And so then here, I would have negative 3. They're all times 1/6, luckily for me, right? So I pull out the 1/6, because probabilities are all 1/6. So I would say minus 3 plus 3 plus 13 plus 27 plus 45 plus 67, all of that times 1/6. You get the picture? Yes or no? That's what you would have had to do had you not already found e of x squared previously. Because here I used that formula that said e of h of x equals summation h of xi times p of xi. That's what I'm using here. So this is alternatively, you would do that. Is everybody okay with this? Let's go to page 3. In the type notes. First question says, for the fair die, compute e of x minus 1. Can you go do that right now? Compute e of x minus 1 for the fair die. Go. What's your answer? How much? 2.5? 5 over 2 is 2.5, right? 2.5? How many of you did not get that? Did not get 2.5? Everybody knows how to do this? Yeah? do I do it the long way like this, or do I do e of x minus e of 1? Which way? Which way did you do it? Okay, let me begin again. How many of you did this problem? How many of you got 2.5? Which way did you do it? Did you do this? Sigma xi minus 1 p of xi? Is that how you did it? Okay, could you have done this? E of x for the fair die minus e of 1. E of 1 is 1. So I could have just found e of x first and then subtracted 1. Could I do that also? Yeah, you have two options. So you could do 1/6. The p of xi happens to be common 1/6 only in this problem. It's not always like that, right? So I pull out the common 1/6 times every x minus 1. So 0, because 1 minus 1 is 0. 2 minus 1 is 1, and so forth. And I stop at 5, because 6 minus 1 is 5. So I'm plugging in 1, 2, 3, 4, 5, and 6 for x, and then I'm adding. So this is 1/6 times 5 and 4 is 9, 10, 11, 12, 13, 14, 15. 15 over 6. 6 2s are 12 and a half. Or I could have found e of x, which of course is 3.5, minus e of 1 was 1, 2.5. Same answer. You can do it however you want it. That's up to you. Let's talk about variance next. But before that, let me label this page. This is page 5. So now I'm on page 3 of the type notes. Do you remember how we defined variance about a month and a half ago? Variance is defined to be the mean of the squared deviations. You remember that? Remember what the old formula for variance used to be? The old formula for variance used to be sigma square equals summation xi minus mu square over n. Yeah, remember that? In that case, all the numbers had the same probability, right? I had numbers like 3, 6, 4, 9, and 8, and I was trying to find the variance. So when I was taking the mean of the squared deviations, it was fair for me to take the sum of all the squared deviations and simply divide by n, the number of values, because at that time, all n values had the same probability. Now, they don't. So I have to change it a little bit, right? This was my old formula when all xi occurred. How do you spell occurred? 2 R's or 1 R? I don't know how to spell occurred. 2 R's? Does that look right? 2 R's? 2 R's. Occurred. When all the xi's occurred with the same probability. This was the case, right? Now, P of xi is different for each xi. So I'm going to say, I want to find the mean of the squared deviation. So I'm going to take the squared deviations, xi minus mu squared. And I want to find the mean of this, E of this, right? Find the mean of the squared deviations. I'm still using the same definition. So to find the mean of some function, you find E of that function, which is like this, right? Summation, let's write the function here, xi minus mu squared times P of xi. Do you see what I've done? If we define variance to be the mean of the squared deviations, then I write that like this. Expectation is another word for mean of the squared deviations. And then, of course, I'm using that formula that says E of h of x equals summation h of xi P of xi. That's what I've used, right? And then I want to clean this up a little bit because this is unwieldy to work with. So I want to do summation. Let's FOIL this out. So this would be xi squared. I'm foiling this term. Minus 2 xi mu plus mu squared times P of xi. The whole thing times P of xi, right? Now let's distribute the P of xi to each term. So this would be summation xi squared P of xi. I'm going like this, and like this, and like this, minus summation 2 xi mu P of xi plus summation mu squared P of xi. Is that fair? All I did was FOIL it and I distribute the P of xi to each. So this first term is E of x squared, because we defined E of x squared to be summation xi squared P of xi. These match up. So this is E of x squared. And for this term, I'd like to pull out the 2 mu. So minus 2. 2 is a constant. I'm going to pull that out. Mu summation P of xi. Summation xi P of xi. I still have a xi sitting here. I pulled out this 2 and I pulled out this mu. So summation xi P of xi is just mu. That's another way of saying E of x. So this term, all said and done, is minus 2 mu squared, because I have a mu here and this is also mu. And this is still E of x squared. And then I have a third term to play with. This is plus mu squared summation P of xi. What is summation P of xi? What is the sum of all the probabilities? 1. So here I have E of x squared minus mu squared, because I have minus 2 mu squared plus mu squared. This is just 1. So E of x squared minus mu squared. That is my shortcut formula for the variance. which is otherwise known as sigma square. This is the formula we're going to use. That's called the shortcut formula for variance. This, of course, would be the real deal. But who wants to do this? I don't want to have to do that. I would rather do this. So this formula should go on your cheat sheet. Let us go and find the variance for the original function that we had when we first started. Let's see what that function was. Something with a minus 40 in it. I'm getting old, can't remember. Minus 40, 7/8, and 2 1/8, right? Let's take a new page. Page 7. So given the following PMF, xi, p of xi, so same PMF I started with, minus 40 7/8 and plus 2 1/8, find the variance. That's the question. So that means I have to do sigma squared, which is e of x squared minus e of x, the whole thing squared. Or mu squared, right? E of x squared minus mu squared. That's my formula, right? Mu is another word for e of x, right? So did we ever find e of x squared for that function? We never finished that problem, right? Shame on us. All right, so that means I have to do it now. Let's do it. E of x squared equals, I'm dealing with this term, summation xi squared p of xi, which is minus 40 squared is 1600 times 7/8 plus 4 times 1/8. So 200 times 7, 200 times 7 is 1400. Plus 1/2. 1400.5. You better check me, okay? Yeah? And then minus mu square. So I forgot what my e of x is, so I'll just find it again. E of x is summation xi p of xi. So that is minus 40 times 7/8 plus 2 times 1/8. So minus 35 plus 1/4 is minus 34 3/4. I found this before. So when all is said and done, sigma squared is going to be 1400.5 minus negative 34.75 squared. Can you please get me an answer for the variance? Or just lend me your calculator? Thank you. So 1400.5 minus 34.75 square. 192.9375. 192.9375. If I wanted sigma, it would be the square root of the variance, which would be 13.89. I want to check this. So I'm going to go, did we already put these in the L1 and L2? Let's see if it's in there. Stat, edit. It's already in there. So how about I just go stat, calculate one variable statistics on L1, L2, and hit enter. and it will give me the sigma. And it happens to match what we did, so everything is good. Thank you. Right? So go stat, calc, one variable statistics on L1 comma L2, and it will give you the mean. It will give you the mean that we got, which is minus 34.75, and it will also give you the sigma, which is 13.89. So you can always check your work with the calculator. Everybody good? Any question on this? Okay. Next page is page 4. There are just two formulas for you to know that we haven't talked about yet. We already said that E of a constant, A, let's say, E of some constant is the constant. We know that. And we also know that when we have E of Bx, where B is a constant, you can pull out the B. I know that already. B E of x. Right? What I didn't talk about is the formulas for variance. So these two you should also know. Variance of a constant is 0. Why is the variance of a constant 0? If you have a constant function, variance measures how much the values differ from the mean. But if nothing differs from the mean, then the variance would be 0, right? If you have a constant function and the mean is that same constant function, nothing is differing from the mean. So it makes sense that the variance would be, variance of any constant is 0, and then variance of a constant times x would be c squared variance of x. So this is the only one that's different. Not only do you pull out the constant, but you square the constant. Okay? So if I gave you a question like this, find the variance of 3x minus 5 for our PMF, you would say this is equal to variance of 3x. Variance of 5 is 0, so it's gone. Right? Variance of a constant is 0, so I can ignore this variance of 5. That's right here. Plus variance of minus 5 here, which is 0. So variance of 3x is 3 squared variance of x, which is 9 variance of x. And what was the variance of x that I just found? It was 192.94. 192.94 from the previous page. You see how I use that? Similarly, if I asked you for E of 3x minus 5, you would say this is E of 3x minus E of 5. E of 3x is 3E of x. I pulled out the 3, that's all. Minus E of 5 is 5. What was my E of x for that function? Let's see. 34 3/4, negative. So 3 times negative 34.75 minus 5. That's how I would do that problem, right? You see what I'm doing, right? So all you really have to know are these four. Put these on your cheat sheet. So let's do the problem on the bottom of page 4. It'll take us a couple of minutes. Page 4 of the type notes. On the bottom, it says, let x and y be independent random variables with mean 75 and 50 respectively. So E of x equals 75 and E of y equals 50. Their standard deviations are 16 and 9. Sigma x equals 16 and sigma y equals 9. Look how tricky, right? They purposely gave you sigmas that were perfect squares so that you would tend to take the square root. But you don't have to, because these are standard deviations, not variances, right? Follow what I'm saying? Okay, the first question says, let L is some linear function of x, let L be 3 plus 2x. Find the mean, variance, and standard deviation of L. Mean of L is E of L. That is E of 3 plus 2x, which is E of 3, which is 3, plus 2 E of x. I pulled out the 2. So my answer is 3 plus 2 times E of x is 75. So my answer is 153. That's E of x. E of L. Sorry, E of L. The next question says find the variance. Find the variance of L. So that would be the variance of 3 plus 2x. That's the variance of 3, which is 0, plus variance of 2x. This is 4 times the variance of x, because you have to pull out the constant and square that constant. So this would be 4 times the variance of x. So that would be 4 times sigma squared x, 16 squared. 256. So 4 times 256 is 1024, right? And then the last question is find sigma of L, the standard deviation of L. That's just the square root. 64. Square root of 1024 is 64, I believe. Can that be? 32. 2 times 16, 32. 32. Thank you.